we now have imagery of interstellar object 3I Atlas as taken from Mars.
It's a technological object that poses a potential threat to humanity.
October 2025. A bright green flash erupts above Mars, then silence. All orbiters lose contact. Data streams vanish instantly. Astronomers track something moving at 60 kilometers per second. An interstellar visitor known as 3I/Atlas. Too fast, too precise, too strange to ignore. What happened out there? And why did Mars go silent? October 2025. The interstellar object known as 3I Atlas approaches Mars, the third confirmed visitor from beyond our solar system. Every major agency prepares for the encounter. NASA, ESA, and Roscosmos coordinate orbital windows. Rovers like Perseverance and Curiosity stand ready to capture surface glows and atmospheric changes. The plan is simple: record history. Multiple observatories focus their instruments where Atlas is expected to pass, hoping to witness a cosmic first, an interstellar object interacting with another planet, not Earth. But as the flyby begins, something goes wrong. Data feeds start to thin out. Telemetry weakens, then stops altogether. Orbiters that usually stream raw visuals in near real time fall silent. No alerts, no public explanation. Hours turn into days, and scientists are left with only fragments, partial logs, cropped exposures, sequences missing frames. Then the amateur astronomy community steps in. Using open-access archives and deep sky trackers, they start digging through what little remains of Mars's imaging data. Slowly, they uncover anomalies that the official channels never mention. Faint trails, odd reflections, and shifts in brightness that seem to follow 3I Atlas's theoretical path. What was supposed to be a routine interstellar observation now becomes a global puzzle, marked by silence, missing data, and one recurring question. If Atlas passed safely near Mars, why did every observation system fail at the same time? Stephen Burns wasn't a famous astronomer, just a quiet analyst from New Zealand who spent nights processing public space data. But in the vacuum of silence after the 3I Atlas flyby, his curiosity changed everything. While browsing NASA's open archives, he discovered a short series of images from the Perseverance rover, captured during the same night Mars went dark. They weren't meant for deep sky tracking, just routine calibration shots. But Stefan noticed something odd. In one part of the frame, a razor-thin line appeared and shifted slightly between exposures. He decided to investigate. Over several nights, he cleaned the images, aligned timestamps, and cross-checked Mars's star field. Frame by frame, the streak moved exactly where 3I Atlas should have been, 60 kilometers per second across the Martian sky. No glitch matched that motion. No cosmic ray artifact stretched so evenly. The trajectory was too precise. Then came the validation phase. Stefan overlaid the streak on orbit predictions published before the blackout. The paths fit within a margin of less than 1/10 of a degree. With cautious confidence, he released his findings online, documenting every line of code and calibration method. Within hours, the video spread across scientific forums and social media. Astronomers, data miners, and skeptics from around the world began replicating his workflow. What they saw sparked both fascination and doubt, a simple, elegant clue in a sea of uncertainty. For the first time, the mystery surrounding 3I Atlas had shape, motion, and evidence outside of official silence. But Stefan's discovery also triggered another wave of questions. If one amateur could recover this data from public archives, what were the agencies armed with far greater instruments seeing behind the scenes? And why, despite global attention, had no official image been released of 3I Atlas since the night Mars went dark? Stefan Burns's discovery sends ripples across the scientific community. Within 48 hours, dozens of teams, from university labs to amateur networks, begin their own reconstructions. Some succeed in repeating his results exactly. Others find nothing at all. Each replication depends on how the data is processed. Different filters yield different outcomes. Some enhance the streak, others erase it entirely. The debate quickly turns from technical to personal. Is the streak real, or a ghost born from algorithmic noise? Then a new anomaly surfaces. In one of Stefan's image stacks, a faint green flash appears, brief, concentrated, and spectral. It doesn't repeat in adjacent frames, and it's absent from the original raw sequence. Was it real light in the Martian sky, or just interference in the camera's sensor? Analysts confront the problem head-on. Some call it proof of atmospheric ionization, perhaps Atlas shedding charged particles as it sliced through Mars's exosphere. Others argue it's a false artifact, the product of imperfect stacking or static bursts from cosmic rays. Online forums explode with theories. Videos claiming evidence of life circulate next to detailed debunking threads. The story gains traction across major outlets, forcing space agencies into uneasy silence. Official statements stay vague, citing ongoing validation and non-verified imaging events. For the scientific community, it becomes a live experiment in collective verification. Citizens with open laptops are now playing the same game as professionals behind million-dollar telescopes. And yet, one question hangs unresolved. If the green flash was an illusion, why did it appear at the exact timestamp when all orbital data was lost? Each attempt to clarify only deepens the mystery. No one can fully erase the glow. No one can fully prove it's real. And somewhere between artifact and evidence, the story of 3I Atlas keeps growing. Pixel by uncertain pixel. 3 orbiters were assigned to one of the most challenging observation tasks ever attempted around Mars. The Mars Reconnaissance Orbiter with its high-rise camera, Cassis aboard the ExoMars Trace Gas Orbiter, and ESA's Mars Express. Each had a specific angle, a predicted time window, and a hope to capture even a fragment of 3I Atlas as it crossed the Martian sky. The challenge was immense. 3I Atlas was moving faster than any known Martian satellite, slicing through the planet's orbital space at over 60 kilometers per second. Without direct tracking capability, the teams had to rely on predictive models updated each day using gravity assist estimates and faint observations from Earth-based telescopes. Every shot was a guess, a calculated one, but still a guess. When the flyby occurred, something unexpected followed. Telemetry from multiple platforms stuttered, then stopped. Even the automated housekeeping data, which logs power levels and system health, showed sudden gaps. Within hours, upload queues for raw imaging went blank. Normally, quick look previews, compressed public images, appear online within days. This time, nothing. Speculation grows fast. Some believe the imaging systems failed due to radiation interference from solar particles amplified by Mars's weak magnetosphere. Others suspect data corruption, a technical glitch wiping stored frames before transmission. But a few analysts propose something different: intentional withholding. With so much global attention, perhaps the agencies preferred to review the material quietly before public release. Weeks pass. No statement, no leak, no release schedule. Then, independent programmers monitoring Mars orbit telemetry notice small but consistent irregularities, minute timing offsets, as if satellites had experienced brief desynchronization during Atlas's passage. It's not proof, but it raises the same uneasy question spreading across online communities. If nothing unusual happened, why did every orbiter's data chain break at the same time? Mars has seen dust storms, solar flares, even hardware failures, but never a blackout synchronized across multiple spacecraft. Something happened that night. Whether cosmic, mechanical, or deliberate, no one can yet say. Tracking an object like 3I Atlas pushes every Mars imaging system to its limit. These instruments were designed for slow-moving planetary features, not for something racing through space faster than any satellite. When velocity eclipses algorithmic thresholds, automated correction pipelines fail. Stars smear, reference points drift, and image processors reject valid data as noise. Inside mission control rooms, engineers and scientists know this well. Releasing faulty or misinterpreted data could lead to global speculation and possibly discredit entire missions. So they take the cautious route: suspend publication, review calibration, and ensure every photon captured tells the right story. That caution, however, looks like secrecy from the outside. Reports mention cosmic ray interference, sensor saturation, and frame misalignment. But to the public, those terms sound like excuses, not science. When the audience wants answers quickly, even silence feels suspicious. Some experts argue that the blackout was procedural, a pause for cleanup after the flyby, nothing more. Others see it as a subtle institutional reflex, fear of being wrong under the eye of the internet. Meanwhile, amateurs continue filling the vacuum. Their tools are less precise, but their transparency wins trust. They post every frame, every line of code, every calculation. The result? Competing narratives. One official, deliberate and slow. The other chaotic, public and immediate. Between them lies a gap, the space where truth usually hides. And in that gap, 3I Atlas waits. An unverified streak across Mars's uncertain sky, suspended between the known and the unknown. Then, fragments of scientific data begin to surface, tiny windows into 3I Atlas's true nature. Spectral readings from Mars Express and the Trace Gas Orbiter reveal something that doesn't fit any known profile. The expected iron signatures are muted, while nickel spikes dominate the spectrum, forming metallic ratios unseen in typical asteroids or comets. Gas analysis deepens the mystery. CO2 emissions surge beyond predicted values, yet water vapor levels remain inexplicably low. There's no broad fan-shaped tail like a comet's. Instead, instruments register a tightly focused jet, a forward-facing spray of material pointing straight ahead of its motion. Such geometry suggests immense internal cohesion, like a single solid mass resisting solar forces. Its trajectory shows no wobble, no outgassing drift, no rotational swing. That kind of stability implies density far higher than any icy body. In short, 3I Atlas looks wrong from every angle. Metallic but volatile, massive yet unnervingly precise. It behaves less like a natural wanderer and more like an engineered relic, though no one dares to say it aloud. Scientists stay cautious, using words like anomaly, outlier, unknown composition. But privately, many admit the same unsettling truth. 3I Atlas is rewriting what we thought we knew about interstellar matter. As data analysts chart 3I Atlas's outbound trajectory, one observation freezes the room. Its projected path, during the Mars flyby, crosses the same sky coordinates linked to the 1977 WOW signal, a short, unexplained radio burst that once stirred speculation across the scientific world. When astronomer Avibay's team runs probability models, the overlap registers at just 0.6%, a rare but undeniable coincidence. No radio transmission accompanies Atlas's passage this time, yet the echo of that historic signal adds a strange symmetry. Two anomalies decades apart, crossing the same patch of interstellar sky. Is it random geometry, or a cosmic pattern we've never recognized? For now, astronomers can only mark the coordinates and prepare for renewed radio sweeps, just in case the silence decides to speak again. By the end of October 2025, 3I Atlas disappears behind the sun. For both Earth and Mars, observation becomes impossible, a natural blackout imposed by solar geometry. All telescopes must wait. Scientists mark their calendars for early December, when Atlas will re-emerge from conjunction. That reopening window could reveal everything: its brightness, its tail structure, its altered trajectory. Until then, silence isn't just absence, it's anticipation. The data gap becomes a ticking clock, a quiet countdown to the moment when 3I Atlas steps back into view and either confirms our theories or shatters them entirely. In science, mystery isn't solved by belief, it's conquered by evidence. Researchers reviewing 3I Atlas gather around four essential pillars: repeatability, multiband confirmation, predictable motion, and non-natural behavior. Only when those align can an anomaly become a discovery. Until then, every spectrum, every frame, every flash must survive replication and cross-verification. The ladder of evidence is slow to climb, but it's the only way forward. And somewhere on that ascent, between error and revelation, waits the truth about what really crossed Mars that silent night. If you found this journey into the unknown captivating, there's much more waiting for you. Dive deeper into mysteries where science meets the unexplained, and keep exploring questions that challenge what we think we know. Don't miss the next story that will push the boundaries of discovery and maybe change how you see the universe forever.